am starting recording now. Okay. So now you have physical box, okay, physical server, which is your hardware. Okay. So the hardware part you will have it. So on top of hardware, you will install OS. Let's say this is your Windows 11. Okay. This is your Windows 11. Okay. And this is your application A. So this is your Office. Office 2020 or something like that. Okay. So then there is one more application like Tally or any other application like your Brave browser or your Chrome browser. Okay. So this is how your physical hardware or physical server will look like. So let's say this is your laptop. Okay. So now you got it. What is physical server?
Yes, sir.
Okay. So now you have a what is this? Virtual machine. Okay. So now what you have done? This is your laptop. Okay. On this laptop you have installed VMware workstation. Okay. So then on top of it you have installed Linux. Okay. So then you can install even Windows also, Windows 10 or Windows 11 or even Windows XP also you can install it here. Okay. You take 1 GB and you can install Windows XP also. It will run very fast, but it will attract lot of virus. That is the problem. Okay. You are running here Fedora or Ubuntu. Okay. So now here what I will do, I will change the color here. Okay. Let me change it to red here. So whenever you are trying to install it, you are installing the entire OS here. Okay. It will take 10 GB. Okay. So Windows 11 or 12 will also take 10 GB total. Okay. Then Ubuntu, let's say this will take 8 GB. Okay. So you are running the complete OS. Okay. On top of OS, you are installing the application. Okay. So let's say on the Windows again. So you have installed MS Office. Okay. Let me tell. MS Office. Then Tally. Then Brave. Okay. On Windows you have installed. Okay. So I will change the color again here. Okay. On Linux you have installed. Let's say on this application 1, application 2 and then application 3. Okay. So this is how you are running it on the virtual machine. Okay. If you have installed and you have done it. Okay. So why I have telling you all this concept is, okay, so if you go for an interview, so you are not bound for only AWS Devops engineering. Okay. So you will not go for AWS Devops. Okay. You will go for Linux. Okay. Then you will go for virtualization engineer. Virtualization also you will tell I know virtualization also. So if you are a core DevOps engineer, you will not care about virtualization. Okay. So you will tell I know virtualization also. I will have a added advantage. So then the Docker anyways, you will have that Docker knowledge. So this is virtualization. Now you have container here. Okay. So recently what we have done, we installed, this is your Windows 11 OS. Okay. This is your Docker engine. You install Docker desktop. Okay. So what this has done is it created a container hypervisor. Okay. So which will be your Windows workstation for Linux, WSL, or a hypervisor. So instead of using here hypervisor, it will take, okay, I will use it only for Docker. I am not going to use it for the entire OS. Okay. So now what host will do here, Docker engine. Okay. So you want to run a application A, application B, application C. Okay. So my application is, let's say I have a, this is my hardware. Okay. And this is my host OS, which is Windows 11. Okay. Now what I am doing, I have installed a Docker desktop. Okay. Docker engine. Okay. We'll do Docker engine. So once we install, you will have a hypervisor here. Okay. So now you want to run, this is your, you want to run Ubuntu here. Okay. So you want to run Alpine here, then you want to run Fedora, then you want to run Red Hat. Okay. You want to run some other OS. Okay. So all that you want to run, just like this, you want to run. Okay. So what you will do, you will get it from the Docker engine. Okay. Image, Docker engine, Docker hub. You go into Docker hub. So I want Ubuntu image. Okay. I want Red Hat. I want Alpine. Okay. I want Fedora. Okay. I want some HPC something. Okay. So I will get this image from Docker hub and I will get it installed. Not installed, I will just get that image here. Okay. 1, 2, 3, 4, 5 images I will download. Okay. I have downloaded this. These are just images. Okay. They are not a complete OS. They are just to image. Whatever you want, I will give it from the OS image. Okay. I am running here the hypervisor here, which will be the Docker engine, WSL, which will be running the Linux operating system here, Ubuntu. If you are running it on Windows, it will be running Ubuntu. If you need to execute something here, it will come here in Docker engine. It will take the OS image, it will run it here on your WSL. Okay, then it will execute and it will go back. That's how it is. Okay. So I am going to use, okay, let's say I want to use only Nginx, which is a website. Okay, I need only 10 MB here. I will consume only 10 MB. Okay. So however, I am taking hard disk here. Okay, I will take whatever the image Docker is giving, I will take that image. But I will use only 10 MB here. Okay. Whereas if I want to run the same here, okay, so I will erase this here. So let's say I will erase all this. Okay. Let's say if I want to run a Nginx here. Okay. I want to run 50 instance of Nginx. Means I want to run a 50 websites. This is my requirement. Okay. So let's say this is my requirement. I want to run 50 websites. Okay. So xyz.com, it should go to port 8081. xyz.in. Okay. If they type, it should go to 8082. So like that I have a requirement, lot of requirement, like up to 50 if you add 31 you will get. Okay, so all that websites are running and hosting in the internet here. Okay, so I want to run 50 websites. Okay, so if I run it here, okay, let's say if I want to run it one by one, I will consume minimum 500 MB minimum at least. So I need to run the complete OS. I want to run it in Ubuntu. Okay, one website. So 1 GB RAM, 1 vCPU, and let's say 20 GB hard disk. Okay, so I am running 500 MB website here. Nginx I am running it here. It will take 500 MB to run this, minimum 500 MB for one OS. Then I am installing one more Ubuntu here, Ubuntu 2, Ubuntu 3, Ubuntu 50. Okay. Then I am running it here 500 MB minimum or 1 GB 50 till 50 I will be running. So I am running this on the virtualization platform. Okay. So now it is completely isolated the OS level here. At the OS you have separated it. Now you are running. Okay. So whereas in Docker I will do, okay, I will install operating system, okay, Ubuntu, okay, you want Ubuntu, okay, I am having Ubuntu. Let's say I don't have Ubuntu, what you will do, you will download Ubuntu image, okay, and you will run, okay, container A, in container A you will run, okay, 50 application in one container you will be running. In container A you will be running 50 application here. So this will be your Ubuntu. Okay, how many you want to run? 50 Nginx. Okay, 50 I will run. Okay, 5 MB each will take. 250 MB you are done. So you will be running this solution. So you want to run it in Ubuntu in Fedora now. Okay, on Fedora you want. So I will create one more container where I will be using this. Okay, container B. Then I will be running a SQL or Postgres database. I will run Postgres 8 database I will run. Okay, 100 MB it will use. So you are sharing the operating system here. Here you are sharing the hardware here. Okay. So that is the difference between VM and a container. Okay. That is how you will be doing the containerization here. Okay. So now we will go back to the documentation, our documentation. So this is how it works. You will have host OS, okay. Then you will have libraries and dependencies. On top of that you will have applications here. Okay. So on physical server you will have maximum performance and you will get direct access here. Okay. So here your utilization will be very poor. Okay. Only you will use only 2% of your computer here. So whereas in VM you will be completely doing a guest operating system. So the pros here is, plus point is, you will have complete isolation. So completely you will be running a different physical hardware on the operating system on the same hardware. Okay. Just like this you will be running different operating system. Cons is high resource overload. Okay. each VM requires its own OS, full OS, okay, which will consume significant amount of RAM, CPU and storage, okay. Per VM you will be using it, okay, and it will take lot of time to boot, okay. Now you see the example here, the hardware, no separation, you will directly access the hardware layer, okay. It will take a lot of time to start here, okay. In virtual machines you will have virtualization level, you will have hardware level, you will be doing a hardware level virtualization. Booting it will take minutes, okay. So you have post here in hardware class, I have told power on self test. This is power on self test. This is directly you are booting from the operating system, okay. So and there is a strong isolation layer here, completely one OS you are having a complete isolation here, okay. So now the it will be heavy because you are doing a complete full OS, okay. Best if you want to be using it for Windows or browser or setting, firewall, all that, this is best virtual machines. Now you have Docker here, okay. Docker is you are virtualizing the operating system itself, okay. Now if you want to start the operating system, this is boot time. It will directly open up in milliseconds. If you want to configure web server, directly it will fire up that web server. Whatever you want, it will start within milliseconds, okay. And here the isolation is, separation is with the process level, okay. So at process level this is separated, that's it, okay. So then you have this lightweight, because only you are using the application. I don't want all that coming up for my particular application. I will just use the OS here and I will be doing it, okay. This is best used for microservices like the containers here, or CI/CD pipeline, okay, or cloud native, okay. We will see what is CI/CD, all that we will see. So this is best used for cloud operations or microservices, okay. So you have Docker engine, you have hardware, host OS, Docker engine. So then you will have containers, okay. So on containers you will be building the applications here. So this is what I just told you, okay, explained. So this is one more example, but in a different picture, okay, in a graphical and much more way to understand, okay. This is how it looks like. Your hardware, operating system, you will have libraries and then dependencies. Then you have applications here, okay. So the antivirus or virus files, they will be targeting these here, okay. If these are targeted, then your application is impacted, okay. Here in hypervisor, okay, in hypervisor you are having Ubuntu here separate, you will have complete OS, then you have Windows OS here, then we have Red Hat OS. For that you are having binaries, separate binaries here, okay, okay, and then you have guest OS here, okay. This is Red Hat, okay. So now you have Docker container. Now you see it here, you have direct hardware, okay. So you are not using any hypervisor here, just like your physical hardware, you are using the host operating system, either Linux or Windows, any operating system, then you are getting a Docker engine here, So Docker engine, what it is doing, it is sharing the binaries and libraries here. Just like this here, you are sharing the binaries and libraries here. It has taken out the guest OS here. Okay. So I don't want you. I will make a image and I will get that particular image. Then I will be using that particular binaries and I will be executing. So I will be giving my binaries here. Okay. Then I will be running that. Okay. So this is how all are similar only. Okay. Now this is the difference. Okay. I will pass the recording now. Okay. So now we will see the containerization in full form. Okay. So see your virtualization, how the VM will look like, the architecture of the VM. Okay. So this will be your container, how container will look like. So same here, your infrastructure, you are sharing the infrastructure layer here, more resources per instance. So you are running VM here, VM1, VM2, VM3 applications, then your guest operating system, and then your libraries and tools here. Okay. So here you are using Docker engine, then you are using a container here for that particular OS. Okay. And then you have container B, container C. Okay. So then you are using the binaries here, means executable. Okay. So that is why it is starting it within millisecond, because you already have the OS here. So I don't want to start it again, because I will be using my OS and I will be giving you. Okay. So let's say an example here. I will take an example. Okay. So these containers are like students. Okay. They are 3 students. Okay. They have come to write the exam, but they have forgot to take the pen. So when they entered into exam hall, professor told, okay, I have 10 pens, you can use my pen and you can return. Once you go, you just return it. So they will just take it and they will write it. They are not going for a shop now. Okay. Now here in virtual machines, okay, in virtual machines you will be using, they will go outside, okay, and they will buy the pens and then they will come to their classroom. So how much time they will take? They will take lot of time. So that is how virtual machines and the Docker, the container will differ. Okay. So this can run it consistently on your laptop or any physical server or even in cloud. So wherever you can put that container, it will run it in the same manner, no matter whether it is a laptop, on-prem server. On-prem means it is on premises, means wherever the customer is, we call that as on premises. Okay. So that is how it will be doing it. Okay. So this will, the key idea is that containers virtualize the operating system, not the hardware here. So they are virtualizing the operating system, not the hardware. Okay. So VMs virtualize the hardware, runs a full guest OS, runs app on top of it. which will be very heavier here. Okay. Whereas containers will run it on the OS on the same kernel, which will be much lighter here. I don't have to take all that burden. I will just be sharing it. Okay. That is what container will look like. Okay. This is all about the theoretical part, how that container is done. All this is all the theoretical part. Okay. So you will have binaries, packages. So you want to do mix up, you want to do the application, packaging, all that, and then you can run it. Okay. So that is what we have tried to do it with one Python application. Okay. So on virtual machine, okay. So you have hardware, host operating system, hypervisor, okay, then your application, then your binaries, then the guest OS. So that is why it is very heavier to start. It is heavier and slower to start. So here it is just OS kernel. That is why it is faster here. So this is all similar only. Okay. So now you will be able to understand it. This is the guest OS. Okay. So you are running the full VM here. Now in the container you are just running the OS and you are sharing the existing OS. Okay. Okay. So now you have Docker engine. Okay. And then you have Docker CLI and you have Docker Hub. Okay. So Docker is the powerful platform for building, shipping and the containers here. Okay. So we will be using Docker engine, okay, which will be the runtime. Means whatever you want to run that container, it will run on behalf of your application. Okay, that is why we will be using the Docker engine here. So you have Docker CLI, which is the command line tool. So where we are using the Docker PS, Docker build, they are all the command line interface. CLI means command line interface. You will just be putting the tool, putting the commands there. It will show you and it will interact with the Docker directly. Okay. And you have something called Docker Hub. Okay. This is the public registry where you can pull or push the container images. Pull means it is already present there. Okay. So this is public registry, you don't have to pay for it. Okay. So if you want to create a custom image, you can also store in the Docker Hub. Okay. So you will just specify it, the image, then you will be able to run it. Okay. So now we will see that in the graphical presentation. Okay. This will be your Docker engine. Okay. So which will build and run the container. So you have command line interface interacting with the Docker. So this is where the public registry where you are going to get those images. Okay. So then you are, once you pull that image, okay, then you will be running that particular application. Okay. So I want here, so let's say this is the client and server architecture. So in the architecture I have told client server, okay, and then 3 tier architecture and n tier architecture, okay. This is just a 2 tier architecture, client and server, that's it. So there is no three tier here, that's it. So you will just call that server, okay, then it will give you that information, okay. So all these are, whatever you are pulling it, these are all read only templates, you cannot do anything here, okay. So you will just pull that image on your laptop or desktop, okay. So this will be your Docker daemon server. So I told you about daemons, right? What are daemons? Okay. So this will be your Docker daemon where it will be serving, okay. So once you pull this image, then the container will start running on that particular container, okay. Nginx you will be running, Redis you will be running, you want my app, it will be running, all that you will be doing. So now you are having a storage here. So network and volumes, you will have a container connectivity here, okay. We will talk that later. So you will have networks and volumes here, how they are interconnected, how they are storing the data, okay. Then how you are pushing and pulling image from public registry, okay. That is how it works. It connects with Docker Hub and it will pull that images, okay. So then this is your end-to-end flow. This is what you are doing, okay. Once you build the Docker, okay, it will create a image, okay, from your Docker file. If you want to create any Docker build, let's say you want to build some web application, okay. My requirement, I have a requirement, okay. So I will go here, I will create one more here, okay. So I have a requirement, okay. I need to have requirement 1, okay, requirement 2, requirement 3, requirement 4, okay, condition 1, condition 2, and then 12 conditions, okay. So I need all these in one container, okay. I want this to be built. So what you will do, okay, so you take all this requirement, okay, and then you will go back, okay. So you will create a build for me, okay, in Docker file. So you will create an image, okay, you will create a Docker file, okay, all with my requirements. So image will be created locally here. You will create a local image and then you will run that container, okay. Once you run that container, okay, so now your application will be isolated in the container, okay. So you will be running separately, the container will be running the complete in isolation, okay. So it will be running here, okay. Then you want to run one more, you will run it here, you will run one more container here or one more instance, okay. So then once you wanted to do, okay, you want to share this to the community, so you will tell, okay, I will put that in Docker image, okay, in Docker Hub. Once you push it, it will be available for everyone now. So anyone can pull your image now. Let's say you have created a image called, okay, let me go back here, okay. So this is my, okay, my web Nix app 55, okay. So something you created this, okay. if somebody wants to use this, they can just pull this image and they can start using your image and they can start running that container. So they have done the open source so that anyone can pull it and anyone can run from anywhere. That is how the Docker is built. So you have this same, okay. So CLI, you are running the application, you are building all the image. Now you are having a Docker daemon. Once you are done it, your Docker file, okay, then you are building it. So you are doing a container. This is optional. You want to push it, you can either push it or you can pull that. If it is available locally, it will check locally. If it is not available locally, it will go to Docker Hub and it will pull that particular image and then it will run. So this is how it will be done. So you can see that in that graphical way how that container is working. Okay. So from past 2-3 days you have been doing this. Okay. So you will get a fair idea on how this is being done. Okay. Your Docker daemon is sending this, and here either you are pushing it or pulling it. So we are pulling the images. So there are more than thousands of entries here in public registry. They are sharing the images and we are pulling it and we are running that on our hardware. Okay, we have done it. Nginx we have done, we have not done Python, or we have done database here. So this is your client server architecture. So when you generate a command or you type a command, you will have a connection. So this is called API. Okay, this will connect to Docker daemon. This is a process. Okay, then in turn it will connect to the container and it will pull that image and then it will run. So this is the overview. Okay, how your base image is. This is your image where it is completely read only. You cannot edit anything here. This is your Docker file. Okay, let's say you are building it a Docker file. So base OS, you can take any OS, Ubuntu, Alpine Linux, anything you can take it, and then you are building the application code and then you are doing a dependency here. Okay, or else you can pull your images and you can do your own configuration and you can build your application also. Okay, once you are done with this Docker file, what you will do, you will run that. You will run locally. Okay, it will create its own file system, it will create its own network interface and its own process tree. Okay, so then once you execute this will create a image. Okay, the Docker file. You can do public registry or you can push it to registry here. So here you are already running it. So if you want to push it, you can push this into public registry. Once you push this into public registry, now you can pull that into any cloud. Okay, you can pull it into AWS, Google Container or Azure. So this is public registry, these are private registry. Okay, so in public, in Amazon AWS, you will not have this Docker Hub. Okay, so you will be using your ECR there. Okay, so we will know once we are done with this, we will start one by one of the cloud and other concepts. Okay, so what are these images? Okay, so we discussed on this all. Okay, so this is all about our containers. I will stop it here. Okay.